Hi guys, so here we want to solve this integral. Here, that is example 7 on in our study guide. Now, unlike the previous question, here we can see that the powers are both even. Now, there's a statement there in the study guide. It says when m and n, meaning that when the powers, right? In this case, this is, say this is m and this is n. So let me write it like this. So sine of mx times cos of nx, right? So now they're saying that when m and n, let's say f of x, not x, mistake. Yeah, because remember it can be 2x, it can be 3x. So now they're saying that when m and n are even, it does not matter which function is replaced by an identity. So it doesn't matter whether you start with the sine or you start with the cos and replace one of them with the identity, because both of them are even. So let me repeat the statement. They say that when both powers are even, it does not matter which function is replaced by an identity. Now, which identity they are referring to? It's this one, where you have sine squared x plus cos squared x is equals to 1. Now, there's one thing I just want to show you, right? Don't confuse these identities. Remember, when we were integrating integral of sine squared x dx, right? We use the identity sine squared x is equals to 1 over 2, 1 minus cos of 2x, right? And when we're integrating an even of cos, maybe let's say 2x dx. We then use the identity cos squared x is equals to 1 over 2, 1 plus cos of 2x. Those are the identities that we used, right? Now, here we'll start first with this identity here because there are two terms. Look at here, we're integrating sine only. And here we're integrating cos only. So meaning that we're going to use these identity, this one here and this one there. But here we will start with this identity over here. The reason being because we have a product of the two. We have a product of the two and both of them are even powers. So as I said, let me repeat. One term, use this identity. One term, use this identity. But there are two terms. You first start with this identity over here. I hope that is clear. So now let's start. Let me just erase so that we can start. So we can start. Now they say solve the integral sine squared x cos squared x dx. Remember I said because it's a product, therefore you'll use the identity sine squared x plus cos squared x is equals to 1. So it doesn't matter because both of them are even. Both powers are even, meaning both powers can be divided by 2 and leave no remainder. So you can choose which one to change or which one to replace with the identity. So now let's choose this one. So if we choose this one, meaning now this identity becomes sine squared x is equals to 1 minus cos squared x. If you chose this one, let's say cos, then it means cos squared x is equals to 1 minus sine squared x. So now let's choose sine x, so meaning that we're choosing to replace sine squared x with an identity. So this will be integral of sine squared x cos squared x dx is equals to integral of 1 minus sine squared x times, sorry guys, remember we said we're replacing the identity sine squared, so meaning that let's erase this one so that we don't get confused, meaning we need to put that one. So this will be 1 minus cos squared x times cos squared x dx. So let's simplify that by multiplying this inside like that and this there, right? So this will then be equals to integral of cos squared x dx minus the integral of cos to the power of 4x dx. Now when you are here, do you see now this is different? Here we had cos squared times sine squared, right? Here we only have cos squared, and here on both integrals we only have cos squared. What does that mean? It means that now you can go and use those identities that I showed you before when you had an even power or when you had an odd power. Look at this. Now your cos squared cos squared is as cos to the power of 2, and the 2 is an even number. And here we also have a cos to the power of 4, and 4 is an even number. Meaning that we can go back to the identity that we used when we had the powers of cos that are even. We said that we replace it with cos squared x is equals to 1 over 2 plus 1 over 2 open brackets 1 plus cos of 2x. That's the identity that we're going to use. So if, for example, you had the powers of sine, it means that you were going to use what? You're going to use sine squared x is equals to 1 over 2, 1 minus cos of 2x. So that's what you were going to use. So meaning that in this case we'll be using this identity over here. So let me erase this one so that it doesn't confuse us. It doesn't confuse us. So before we use that identity, look at the power here. The power is cos to the power of 4, and our identity says cos squared x. So meaning that we have to do some changes there. So we then have to write cos to the power of 4x as cos squared x to the power of 2, something like that. So let's rewrite that. Okay, so now this is equals to the integral of cos squared x dx minus the integral of cos squared x squared dx. So now we can then continue. So let's replace with the identity. So this is equals to the integral. So replacing with this particular identity. So this is equals to 1 over 2, open brackets. Let me remove this bracket. 1 plus cos 2x dx. Right? Minus, now replacing here, integral. Remember that the cos squared is inside the bracket. So you need to put brackets. It's this cos squared, substitute, so it should be 1 over 2, 1 plus cos 2x all squared dx. So then we can simplify. Normally, I like taking out the constant if there's a constant, or you can also multiply the constant inside. It's basically up to you on how you do it. So for me, I'll just take out the constant here, which is the half. So I'll say 1 over 2 integral of 1 plus cos of 2x dx. Sometimes some of you will like to remove the brackets. The brackets, it's still fine. But I like putting inside the brackets sometimes. So minus, now let's be careful. Look at this term. This term squares everything inside, meaning it squares this, and this becomes 1 over 4, and also squares 1 plus cos 2x squared dx. So now let's simplify. So now this is equals to 1 over 2, the integral of 1 plus cos of 2x dx. I'm taking out the 1 over 4, 1 over 4. Then we say integral of, so this becomes the integral of 1 plus 2 cos of 2x plus cos squared 2x dx. Okay. Now, if we look at this term, this is a very long term. I mean, if we look at this expression, not a term, if we look at this expression, it's a bit of a long expression. So you can do it, if you want, you can do it all together up to the end, or you can split it. So for example, this is what I'm going to do. I'm going to start with this one over here, right? Do all this and finish, get the answer. And then I come back and do this part over here. Get the answer and then subtract them. So now let's start with the blue parts. Right? Let's start with the blue parts. So let's see if we have space here or we have to create. So we have enough space for the blue parts. So let's start with this one. Okay, let me choose a different color. So the blue part says we have 1 over 2, the integral of 1 plus cos of 2x dx. Now this can also be written as 1 over 2. Be careful because there's a half negative. There's a half outside. So you can put everything in a square bracket. So this is the integral of 1 dx plus the integral of cos of 2x dx. Okay? Now, the first term is easy to integrate this term over here because we know the integral of a constant is that constant times x, right? So this is equals to 1 over 2. The integral of a constant is constant times x. So this becomes x. Now, the issue becomes here. Look at this one. This is what? This is cos 2x, meaning that we're going to use the formula. Okay, with that formula, we're going to use the formula that says if you integrate f of prime of x times cos of f of x, then dx, then this is equals to sine of f of x plus c. Now, let's look at what is the function in this case. So our function in this case is 2x. So this is 2x. And we know that our derivative of this function is equals to what? Is equals to 2. So if we substitute here, we have a 2 times cos of f of x is 2x, meaning that we can't use this formula yet because if we look at our original, that the one we have, we don't have this 2 over here. Now, for us to be able to use this formula, we need to introduce a2. And remember, we can't do that, especially because a2 is a constant. So then it means that we'll say plus the integral of 2 over 2 cos of 2x dx is equals to 1 over 2, then x plus, now we can write this as 1 over 2 times 2 cos of 2x dx, because we're looking for the 2, so we can take out the half outside. So then this is equals to 1 over 2, x plus 1 over 2, integral of 2 cos of 2x dx. Now you can see that it looks like this one here, which is the derivative of a function, which is 2, and the cos and the function. So meaning that this over here, we can say this is 1 over 2x plus 1 over 2. This becomes sine of what? Sine of 2x plus c. So this is then equals to 1 over 2x, we're multiplying the half inside now, plus 1 over 4 sine of 2x plus c. So meaning that we have found the answer for the blue part, this part over here, which is equals to 1 over 2 times x plus 1 over 2 sine 2x plus c. So we are left with the green part over here. So we'll make space so that we can be able to integrate the green part. Once we integrate the green part and get the answer, we'll then come back and what? We'll then come back and subtract it from here. Sorry. We'll then come back and subtract it from there so that we can actually get the final answer for the whole integral. Okay? Now let me make some space and then we do the green parts. So now let's do the green part. So we have 1 over, so sorry about that. Okay, so we have 1 over 4. Okay, put in big brackets, integral of 1 plus 2 cos of 2x x plus cos squared 2x dx. So what we can do is we can just write it like this, where we say this is 1 times dx plus plus the integral of 2 cos of 2x dx plus the integral of cos squared 2x dx. Okay. Now you can see the first term is actually a constant. So it's the integral of a constant times x. And then the second one is what we did apply there, where we have a function and f of x, meaning that we apply the integral of f of prime of x cos of 2x dx is equals to sine of f of x. Now the third one, it's where we then have to use the identity. But let's write and then we come back. So this will be, this will be 1 over 4. We said this will be x, right? Plus sine of 2x, right? Plus, now let's focus on this one. Integral of cos squared 2x dx. Now, because the power of cos is an even number, so it means that we go back to our identity where it says that if you have an even number of cos and you're integrating, therefore you are going to use this particular identity over here, which says cos squared x is equals to 1 over 2 plus 1 plus cos of 2x. Now, one thing you need to also keep in mind is that this says x is equals to cos of x is equals to that. And we do not have cos of x. Instead, we have cos of 2x, meaning that in our identity formula there, or in our identity, where we see x, we then have to substitute what? We then have to go and substitute 2x instead. So let's do that. So this becomes cos squared. I see x, I'll put 2x is equals to 1 over 2, 1 plus cos of 2, where I see x, I put 2x. So then this becomes 1 over 2, 1 plus cos of 4x. Do you see that? So meaning that for cos squared 2x, we're going to substitute 1 over 2, open brackets, 1 plus cos 4x, right? So let's do that. Okay, let me erase here so that I make space. So let's go and substitute. So let's see. Let me go back to the color that I chose that I was working with. So now this becomes, so this is equals to 1. Okay, I need space here. So this is equals to 1 over 4 x plus sine 2x plus the integral of 1 over 2, 1 plus cos of 4x dx. I hope we are all together up to that point. So as I said, I like taking out the constant outside the integral sometimes so that it's easier for me to work. Now 1 over 4. Remember the 1 over 4 covers everything inside here. It covers all alles, everything there. So this becomes x plus sine 2x plus 1 over 2, the integral of 1 plus cos of 4x dx. So now this is equals to 1 over 4, open bracket, x plus sine of 2x plus 1 over 2. Be careful. This 1 over 2 also covers everything in there. So meaning that I can put another bracket in there like this. So this will be integral of 1 dx plus the integral of cos of 4x dx. Hope we are all together up to that point. So now this is equals to 1 over 4 x plus sine of 2x plus 1 over 2. Remember, the integral of a constant is a constant times x in this case. So it's x. Now here, something is missing. Remember, this, we know the formula will be like this. So it will be the integral of f of prime of x times cos of f of x dx, right? It will be something like that. This is then equals to sine of f of x plus c. Now, we do have this cos of f of x, which is this one over here. But the derivative of f of x here is, if we look at f of x is, if we choose f of x here, f of x is equal to 4. Meaning that the derivative of f of x is equals to, 4x. Meaning that the derivative of f of x is equal to 4. So we are missing f4 here for us to be able to use this formula here. So what can we do? We can introduce the 4 as we've been doing. So meaning that this will be plus the integral of 4 over 4. We know 4 over 4 is the same as 1. So what we're doing here, it's not mathematically illegal. So it's not illegal in mathematics, so it's correct. It can be done. So let me erase here so that we make more space. So this is then equals to 1 over 4 x plus sine of 2x plus 1 over 2. Remember, x plus, remember that half, covering everything. Integral of 1 over 4 times 4 cos of 4x dx, cover everything for that 1 over 4. So then this is equal to 1 over 4 x plus sine of 2x plus 1 over 2, cover everything, which is x, plus, so we can take out the 1 over 4, so that's 1 over 4 integral of 4 cos of 4x dx, cover for the half and cover for the 1 over 4. So here we need more space. So let me erase. I hope you following all the steps. Yes, it's a bit of a long problem, but as long as you're following all the steps, that's what matters. If you don't understand, send me an email. Okay, so now let's continue. Then this is equals to 1 over 4. Remember the big bracket, x plus sine 2x plus 1 over 2, x plus, now here we can write this as 1 over 4, 4 cos of 4x, x, the bracket that covers the half, and the big bracket that covers the 1 over 4. So this is 1 over 4, x plus sine of 2x plus 1 over 2, x plus, take out the 1 over 4, because remember we're looking for the 4. So then it's 1 over 4 integral of 4 cos of 4x dx. Now from here, we can see that we can then be able to apply that formula, that one. Remember that one. It says f of prime of x cos of f of x dx is equals to sine of f of x plus. So then we can do that. So this is 1 over 4 x plus sine of 2x plus 1 over 2. Let me erase here. 1 over 2. Then we have, that's x plus 1 over 4 times now sine of 4x, all plus c. So always put the c outside, because remember that when we were differentiating, there might have been some constant c that you have differentiated. And we know that when you differentiate a constant, then we know it's equals to 0. So this is now then equals to 1 over 4, big brackets for the, remember there's a big bracket for the 1 over 4, so x plus sine of 2x plus. Now multiply all this inside this half, multiply by that, plus that multiplied by that. That half multiplied by that term. So this is equals to 1 over 2x plus 1 over 8 sine 4x. Okay, so now this is equals to 1 over 4. Let's now add the like terms. So if you take this one and add by this one, this will give you 3 over 2. Let me see, where's my calculator? Let me just check. Yeah, it should give you 3 over 2. So we say 1 plus 0, 5 is actually 3 over 2. I was right. So this is, okay, sorry about that. Let me change the highlighter. So this is 3 over 2x plus sine 2x plus 1 over 8 sine of 4x. Okay, now look at this. We now then have to multiply with that 1 over 4. So multiply all the terms with that 1 over 4. So you need to be careful, especially when you take out the constant outside the integral sign. Always put that big bracket so that then all your terms are multiplied times. So then we know that this 1 over 4 times 3 over 2x, we know that this will be 3 over 8x. Okay? Then we know that 1 over 4 times sine 2x, this will be plus 1 over 4 sine of 2x, right? Then we know that 1 over 4 times, okay, let me put it in the calculator just to be sure, plus 1 over 80 is equals to, not plus, times, easy, times, this is equals to plus, sorry about that, so plus 1 over 32 sine of 4x plus c. So meaning that now we have actually calculated the green parts. My green parts is this one. Let me just remind you. Remember, we had this one, this part here, where I said that, okay, let me remind, where's the highlighter? This is what we first started with. And the answer that we recently got, it's for this part, the green part over there. So now we then have to go and substitute both. So the green part, the answer is this one, which is 3 over 8 x plus 1 over 4 sine 2x plus 1 over 1 over 32 sine 4x. So then we go ahead and substitute those ones so that we can be able to get the final answer now. Now, let's go back. Just a reminder. Okay, let's just go back. Forget about the reminder. Let's go back. Now, I hope you did save the answers on a piece of paper. When integrating this term, what did we get? We got 1 over 2x plus 1 over 4 sine 2x plus c. That's what we got. Minus, what did we get on this green term here? You need to be careful. So that minus will affect your answer if you don't put every term that you got for the 1 over 4 for the green part into the brackets. For the green part, we got that this was 3 over 8x plus 1 over 4 sine 2x plus 1 over 32 sine 4x, then plus c. Sorry. There's a plus c, so put a plus c. So now this is equals to 1 over 2x plus 1 over 4 sine of 2x minus 3 over 8x minus, because this minus times this, positive times this, times that one, minus 1 over 4 sine of 2x minus 1 over 32 sine of 4x plus c. So now let's group the z-like terms. So if we say 1 over 2 minus 3 over 8, what do we get? We get 1 over 8. So this is 1 over 8x, right? And then this term, you can see 1 over 4 sine 2x minus 1 over 4 sine 2x, that's 0. And then which term are we left with? Okay, so then we're left with minus 1 over 32 sine 4x plus c. Therefore, it means that we were able to solve our integral, which is sine squared x cos squared x dx to be equals to 1 over 8 x minus 1 over 32 sine of 4x plus c. Now, just to recap, okay, my handwriting. Now, just to recap, we said that if you're multiplying, if you're finding the integral of sine to the power of something times cos to the power of something, and if those something are even powers, both of them, it doesn't matter which one you use to change which one you use to replace with the identity. So we are saying that when you are here, the identity that you need to replace is sine squared x plus cos squared x is equals to 1. Meaning that if you decide to replace this one over here, you replace it with sine squared x is equals to 1 minus cos squared x. But if you decide to replace this one, you replace it with cos squared x is equal to 1 minus sine squared x. Now, because there's a product of sine and cos, you do not go and start with those identities that we learned if there's a single term of cos squared x dx or a single term which is sine squared x dx. You do not start with those ones. Let me remind you those identity. Those ones says cos squared of x is equals to 1 over 2, 1 plus cos of 2x. And then the sine one was sine squared x is equals to 1 over 2, 1 minus cos of 2x. You do not start with that when you have a product like this, where you have cos times sine, sine to the power of something times cos to the power of something. You do not start with that thing. You only start with these ones. The sine squared plus cos squared is equals to what? Is equals to 1. Now the statement on page 17, let me repeat it. It says when m and n are even, it does not matter which function is replaced by an identity. Meaning that in our case, we decided to replace this one first. But if you could have decided and say, okay, fine, I don't want to replace sine squared first, but I can replace what? Cos squared. Meaning that you will replace with where's that identity? This identity here. So meaning that this will become 1 minus sine squared x dx. Then you have to go and do the multiplication and all that and all that and what we want. So that's it for now. Thank you very much. Bye.